So what I want to do is just briefly review some homework that you guys did on Monday. The one homework assignment that for some reason I decided to tell you about the word problems, and you needed to do the stuff before getting to the word problems. That was stuff that looked like this. Oh, let me go to black. Okay, so you had this equation and your directions told you to solve. So what strategy did you use to solve this particular problem? This is from Monday. Okay. Trent. Then you did it wrong. This would not be using a matrix on this one. I'm supposed to solve for y. I'm not going to use a matrix. Emily.
I took the square root of both sides.
I've got a quantity squared. I want the variable to come out. What I'm going to do is take the square root of both sides. But because I took the square root of a variable, I have to write plus or minus on the other side. So when I solve this, I got the quantity y plus 2 squared. The square root of that is y plus 2 equals plus or minus, and the square root of 16 is 4. I wasn't quite done because I still had something going on with the y, so I did opposite operations. We are taking notes, so you should be writing. Subtract 2 from both sides. And we get y equals negative 2 plus or minus 4. Now, I have a number and I have some numbers. So guess what? I can do some math if I have only numbers. So my two cases was the positive case, the adding case. Oops, where I get, try that again. Y equals negative 2 plus 4. And then I have the negative case where it's y equals negative 2 minus 4. So I get y equals 2, and I get y equals negative 6. So my solution set contained 2 and negative 6. And then the problem changed a little bit. And sometimes what you had was something like, oh, by the way, what do those values represent? The 2 and the negative 6?
Y coordinates?
Nope, not y coordinates. Not the vertex. Justin Pratt?
Solutions for y?
Nope, not solutions for y. This is a quadratic equation, folks. Really doesn't matter what variable it's written in. What are you solving for when you solve for the variable? The what?
Intercepts?
Intercepts? What kind of intercepts?
Y.
The x-intercepts. Doesn't matter what variable it is. This is telling you the roots of your equation. In other words, where does your parabola cross the x-axis? Okay? Doesn't matter the variable. I just chose y just because. So, just to make it better for y'all, let's do this. So now I have, oh, let's change it from 2. Let's do another number for crying out loud. So we had the quantity x minus 4 squared was equal to 12. And again, I'm supposed to solve this. I want to get x alone. He's part of a binomial that's being squared, so the easiest way to deal with this is to take the square root of both sides. But because I'm taking the square root of a variable, I'm going to have to write plus or minus on the other side. Mr. Bradbury, I don't see you writing. So I get the quantity squared, square root of, gives me x minus 4. The radicand comes out. And over on this side, I actually have to simplify that radical. So 12 is the same as 4 times 3, so I'm going to take the square root of 4, which is 2, and the leftover is the square root of 3. So then I'm still not done. I need to add 4 to both sides to get the variable alone. And we get x equals 4 plus or minus 2 radical 3. Now, the reason why, Trent, I said, nope, what your way is not a good way is because you couldn't get this answer for the second problem if you try to factor or FOIL out or multiply out your squared binomial and then get everything on one side, 0 on the other. This one, you couldn't possibly get this answer because at this juncture, we don't really know how to solve when we don't have factors, okay? When I can't play the game and I can't come up with factors. That's what we're talking about today, and then next week, the biggie is coming, okay? So, and this is more realistic. Life doesn't work out beautifully all the time. It comes into irrational or parts of things that we're not used to seeing. So that's what we're going to be seeing a lot more because that's more of a realistic answer. We still have 2 answers. There's a 4 plus a 2 radical 3, and then there's a 4 minus a 2 radical 3. This is precisely why I don't teach you that you need to find your intercepts for your parabola as part of your chart, because how the heck are you going to graph 4 plus 2 radical 3? Or 4 minus 2 radical 3? Or looking at your graph, how could you tell that where across the x-axis was either one of these? So while it's important to know and we use it in calculations, it is not the driving force in how we graph. Okay, fantastic. And then I think you saw something that looked like this. Where they gave you a trinomial and it was equal to some number. Now, of course, the temptation is to get everything on one side and 0 on the other, but chances are you were going to find you run into a problem. For here, we'd get what are factors of -6 to add to give us 4. We can't constantly say there's no solution to our problem. There is. It's just not through the way that you understand. So what you thought about was, how can I get the left side to look like the left side in the other problems? Okay? What would you need that trinomial to be in order to do anything to it? Chandani? Yeah, and how? What kind of trinomial is it? It has to be a trinomial square. The only trinomial that I can factor into a binomial squared is a trinomial squared. So you recognize this is a trinomial square. Yay! So when I do that, I'm able to factor this. And you may go through a fast process, a short process, take the square root of the first and the last, sine of the middle, double that, bam. And now it looks just like the other problems. But I had to do this prep step to make it look just like the other problems. And then I would continue to solve it. Square root, I get square root of a quantity squared as the quantity equals plus or minus square root of 10. I'm going to subtract 2 from both sides. And I get x equals -2 plus or minus the square root of 10. And so again, my solution set would be -2 plus or minus radical 10. All of that was what showed up on that 583. But my question is, what if this is your equation? Okay, so we have something like this. Is that a trinomial square?
No.
At this point, we're stuck. But we're told you have to solve this. You can solve this. So what we're going to do is learn a process that's going to allow us to create a trinomial square. And this process that we're going to talk about today is called completing the square. Okay, so that's our objective today, is to understand how to complete a square. Now, what they're talking about a trinomial square. Okay? All right, so let's go back to this guy right here. So we're going to go through this process, then we'll write down the steps. So I've got x squared plus 6x plus 7 equals 0. Come on, Bubba. All right. So step 1 is I need to make sure that I have something that I can complete. The 7 is mucking up this whole process. So what I'm going to do is I'm going to get the 7 to go to the other side. So I get x squared plus 6x equals negative 7.
My question, do you have to subtract the whole number, like if it's a 7? Do you have to
Yes.
subtract? Okay.
So what I need to do now is to make sure, what's going to be the easiest for me thing to do to create a trinomial square is to make sure that my quadratic term has a coefficient of 1. We're lucky that this problem does. If it doesn't have a coefficient of 1, we'll divide everything by that a value to get so that my front term does have a coefficient of 1. So if you remember when we were talking back in chapter 5, and I said it's really important that you guys learn this because it's going to come up several times down the line, well, this is the time it really comes to play. When we were trying to take a binomial and square it, we talked about multiplying the two terms and doubling them would give us the middle term. So I have to think, what number could I multiply x by and double to get the 6? So instead of trying to guess it that way, I'm going to do opposite operations. The opposite of doubling, which is to multiply by 2, would be to divide by 2. Now, what we're going to do, instead of thinking about it as dividing by 2, we're going to think about it as multiplying by 1/2. And you'll see why that becomes really important in a little bit. So what we're going to do is take this coefficient, I don't worry about sign, I just look at the number, and I multiply it by 1/2. 3 is not a perfect square, and I know my trinomial square needs to end with a perfect square, so I'm going to do my next step is to take that value and square it. If I add that to the x squared plus 6x, now I have a trinomial square. But it's an equation, so if I add that squared value to one side of the equation, then I have to add it to the other side of the equation as well. Now I can factor the left side because that was the whole point to what we just did. And I'm going to get x and plus and 3. That quantity squared equals negative 7 plus 9 is 2. Now, why did I color him blue? Why is the 3 blue? Where do you see a blue 3? Donovan?
In the line above it, when you, after you times the 6 square half.
Okay. When I took my linear coefficient and I multiplied it by 1/2, I got 3. This is not a coincidence. The number you got when you took half of your linear coefficient is the number that should show up in your binomial when you factor. Okay? Yeah, all of this making sense. All right, so now we're back to the problem we did on homework. Now I'm ready to take the square root of both sides. Plus or minus, square root. I'm going to continue over here, and I get the quantity squared. When I take its square root, I get the quantity, so x plus 3 equals plus or minus square root of 2. Last step is to get the x completely alone, and to do that I subtract 3 from both sides, and I get x equals negative 3 plus or minus radical 2. That is my solution. I have no ability of getting that answer based on what I know what to do that we've talked about in this class so far. Okay? So completing the square is one more method we're going to use. And I'm going to tell you, it's not a method that I'm going to suggest that you use because we're going to use this guy to help us learn our last method, and he's the next one that I would be using. But here's the gist. I'm going to make you come up with or derive the last way of solving quadratic functions, which is called the quadratic formula. And you're going to apply completing the square to standard form quadratic function of ax squared plus bx plus c equals 0. Every one of you is going to do it. It's going to be on the test, and it's not that big of a deal if you understand the process. So let's write down steps. Number 1, we're going to take the constant to the left, or to the right, excuse me. So here's our quadratic function, it is not working, I can't factor it, cannot play the game, it is not a trinomial square, I got nothing. I'm an empty at this point. So this is my process. So I take the constant to the right using opposite operations. The sign will dictate which one I get to do. If the quadratic coefficient that's your A value, does not equal 1, divide, and I'm going to everything, everything, every term by the A value. The reason to do that, it's going to create a 1 for your quadratic coefficient. It is far easier to come up with your missing perfect square number at the end. Now comes the weird step. Multiply the linear coefficient by 1/2. That's the first bit. Square that number, then square it. This is the most important step. Twofold. Multiply the linear coefficient by 1/2, then square it. Add this squared value to both sides of the equation. Creating a trinomial square on the left. Factor the trinomial square. Take the square root of both sides. Don't forget the plus minus on the right. That's the one thing kids forget all the time. Remember, you should be getting 2 answers when you're doing this. Okay? Now, you may have to do an extra bit, because remember, you have a binomial on the left side, so you are going to have to solve the remaining equation, which is going to be a simple adding or subtracting step. Chloe?
What if, like, the B value is odd and it doesn't...
You're going to get a fraction. That's why I tell you to multiply by 1/2, not to divide by 2. You multiply by 1/2, you get a fraction, you square it. Square the numerator, square the denominator. It's not a big deal. Where the big deal happens is now you have to add a fraction to a whole number on the other side. Okay? So what I'm going to do is I'm going to cut the notes off here, but I'll do 2 examples as a part 2, one of which will have that exact situation happen so you can see a real model of that too. Okay? All right. Good job, guys.